Scientists don't only study planets, but also their weather. And on one of the planets in the solar system, there are storms 1.3 times the diameter of Earth, and raging with a force that's hard to imagine. What's going on with Jupiter? And why is it so important that everything is okay with the gas giant? Our ancestors knew the monstrous size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system, and 317.8 times the mass of the Earth. Jupiter's volume is 1,300 times larger than our planets. But today, we've advanced technologies that help us learn more about the gas giant than just size and mass. And astronomers pay a lot of attention to the study of Jupiter, as our planet's future depends on it. The latest data we have shows that, right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the solar system by astronomers because of its immense gravity well and where it orbits in the inner solar system. The gas giant has taken some huge impacts from asteroids that could have hit Earth in the past, like Shoemaker-Levy 9, which slammed into Jupiter as it broke into pieces in 1994. But the planet's gravity isn't always protecting us. Along with Venus, it affects the Earth's climate. Every 405,000 years, gravitational fluctuations between Earth, Venus, and Jupiter bring us abnormally cold winters and hot summers. Droughts become severe and rains cause floods. Researchers say we're now somewhere in the middle of this cycle. And if something goes wrong on Jupiter, it could affect Earth in a big way. So what is the weird thing going on with Jupiter? For once, its most famous storm seems to be shrinking, and we have no idea how that will affect the planet. The Great Red Spot is a huge anticyclonic storm on Jupiter. The largest storms on Earth are more than 1,600 kilometers across, with winds reaching up to 320 kilometers per hour. But these hurricanes pale in comparison with the Great Red Spot anticyclone, which is about 16,000 kilometers in diameter. The gigantic storm is circling Jupiter at 650 kilometers per hour. Astronomers discovered the Great Red Spot in the 17th century, and scientists still study this phenomenon. The distinctive color of Jupiter's Great Red Spot has been a mystery for a long time. Some scientists believe the storm is colored by complex organic compounds. The whirlwind lifts them from the inside of the planet into the upper layers of the atmosphere. Others think the rusty color comes from sunlight splitting up different chemicals in the anticyclone's upper atmosphere. If so, the storm isn't actually very red at all, and what we might see is just a sort of sunburn at the top of it. Another interesting question is why the anticyclone lasts so long. Scientists have suggested it's because of Jupiter's composition, which is mostly hydrogen and helium. The gas giant has no solid surface to frictionally weaken the storm. On Earth, friction reduces the wind speed near the surface. This slows down storms. But other planets in our solar system aren't like the Earth either. Saturn, for example, isn't rocky, and storms there don't last this long. The biggest storm on Saturn, the Great White Spot, covers several thousand kilometers. You can see it through a telescope as a white oval. This spot appears every 30 years and then vanishes without any trace. The Big Dark Spot on Neptune, which was discovered in 1989, was also proved to be short-lived. The wind around the storm reached supersonic speeds of up to 2,400 kilometers per hour. The large dark spot was constantly changing its shape and size. With that much activity, the storm was clearly not going to subside, and yet, in 1994, it disappeared. But let's get back to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019. It took images of the storm to help determine its nature. Using Juno's data, scientists compiled a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much deeper than previously thought. On Earth, a storm of this size would rise above the International Space Station. Researchers say that, taken from above, the cyclone looks like a huge pancake, but a really thick one, going 500 kilometers deep into the clouds of Jupiter. This is 50 to 100 times deeper than the Earth's oceans. The storm is powered by atmospheric jets that go far deeper, about 3,000 kilometers. Scientists are still trying to unravel the mechanism behind how these jets move. So far, there's only one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the jets. This is very different from the way things happen on Earth. On our planet, atmospheric phenomena are largely driven by water, clouds, condensation, and sunlight. This is what we'd probably see inside the Great Red Spot if we could get there. The gravity there would be intense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and stretched. Thanks to this effect, scientists picked up tiny tremors, 0.01 millimeters per second, and were able to calculate the gravity inside the storm. It turned out to be so strong, as if a mysterious planet was hiding at the bottom of the anticyclone. But of course, scientists didn't find any planet there, only a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its form from oval to round and shrunk considerably. Previously, 3 Earths would fit inside the monstrous storm, but now only 1. Look at these Hubble telescope images from 1995, 2009, and 2014. You can see how the Great Red Spot has shrunk in just 19 years. So why is the storm on Jupiter shrinking? And do we have anything to worry about if the storm disappears? According to researchers, something in the planet's atmosphere is killing the storm. An unknown force is tearing apart the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that looked like a wave peeling off its eastern side. The Juno spacecraft also took an image of red flakes flying away from the spot. Researchers confirmed that formations of various shapes actually detach from the Great Red Spot and scatter into space. These huge chunks, up to 100,000 kilometers in size, are about the size of Portugal or Iceland. Computer models show this is a very natural phenomenon for Jupiter's complex atmosphere. It may happen due to the convergence of the Great Red Spot and smaller storms. On Jupiter, anticyclones are attracted to other anticyclones, and opposites, such as cyclones and anticyclones, repel. The merging of anticyclones is a long process. In the beginning, a smaller storm becomes a small bulge closely adjacent to the larger hurricane. Then, the larger storm merges with the smaller one. But when anticyclones meet with cyclones, something different happens. A clockwise rotation of an anticyclone and a counterclockwise rotation of a cyclone first bring them to an abrupt halt. Then the motion resumes with an unimaginable force and scatters the storms in different directions. A small anticyclone wouldn't merge with the Great Red Spot but shatter into pieces instead, and these pieces of different shapes would then separate from the storm. This is what astronomers believe they are observing. And the Great Red Spot is still shrinking. According to scientists' calculations, it could disappear in about 20 years. Jupiter is unlikely to be affected, but there may be some irreversible processes that the storm was preventing. Only time will tell what will happen when the storm completely disappears. Based on data from the Hubble telescope, the average wind speed around the red spot increased by 8% from 2009 to 2020. And this means the anticyclone isn't losing activity and may increase in size again. Or it could be replaced by another storm. In 2000, 3 small oval white vortexes on the planet merged together. And at the end of 2005, a new hurricane turned red. Astronomers called it the Small Red Spot. In 2006, the Small Red Spot came into contact with the Great Red Spot. Because this was a slight collision, it didn't have any significant effect on the 2 whirlwinds. But how will the 2 storms get along in the future? To sort things out, NASA's mission Juno was extended for 5 years in 2021. The spacecraft will monitor mysterious polar cyclones, the planet's magnetosphere, and its incredible red storms. Jupiter continues to be studied by the Hubble and Webb space telescopes, as well as many ground-based observatories. What else could scientists find on the gas giant? And what's in store for the famous Great Red Spot? Let us know what you think in the comments, and be sure to subscribe to the channel so you don't miss out on anything incredible happening in our universe. Thanks for watching.